Hello everyone, my name is Jari DECANO, and today we're going to explore everything about the sine function from start to finish. But first of all, what is a sine function? Well, in basic terms, a sine function is what you call a trigonometric function. Now imagine a unit circle with the radius 1. Now, place points on both the x and y axis and then draw a line between the 2 points. That is what you call your hypotenuse, which is the longest side of a right triangle. Now, a sine is basically the ratio between the opposite side of an angle. For example, this is angle theta. Theta is what you use for unknown angles. So the side opposite to it, which has a radius of 1 or a side length of 1, over the hypotenuse. So sine is equal to opposite over hypotenuse. And that the fact that this is a ratio between opposite and hypotenuse, you would have an answer. Let's say this is square root of 2. You would have an answer of sine theta is equal to 1 over square root of 2. Now this is the sine of theta. So that's basically what a sine function is. Now we can finally move on to talking about the actual function itself, the sine function. Now the function is usually written like this. Y is equal to a times the sine of the quantity b times x. Now this is actually a very simple function. Let me draw out a sine wave here. It doesn't have to be perfect. Now there are three main components, or just two main components here that we have to take into account. First is a. Now a is the amplitude of the sine wave, which means how high and how low it can go, which is basically the upper limit and the lower limit of the sine wave. For example, we have a is equal to 4, which means the upper limit is y equals 4, and the lower limit is equal to y is equal to negative 4. Now, the letter b is the frequency of the wave, which means how narrow or how wide a wave can be. Now, if it's greater than 1, positive 1, then it gets narrower. For example, 2 or 3 or 2, any number higher than 1. And if it's lower than 1 but greater than 0, for example, 0.5 or 0.6, it gets wider. And so that's how you know what to change in a sine wave. Now we can move on to actually translating these sine waves. And that is expressed through y is equal to a times the sine of the quantity b times x plus c, parentheses, plus d. Now, plus c over here, this is where how left or how right, horizontally, the graph will go. So if it's negative, the graph will go to the right, and if it's positive, the graph will go to the left. And for d naman, d goes up or down. So if it goes positive, it goes up. If it goes negative, it goes down. So this is our translation for the graph. Now we can move on to the key features of sine functions. Now, all we have to know about sine functions is that it goes on from negative infinity to positive infinity, which means that the domain of these functions are always from negative infinity to positive infinity. But the range is a different story. All we have to remember is that the range always depends on what your amplitude is, unless it is translated up or down, of course. But generally, it always depends on what your amplitude is. So let's say your amplitude, or A, is equal to, let's say, like 7. Now, the range would go from included negative 7, positive 7. That's about it. Or let's say the range is the A is equal to 4. So negative 4, positive 4. It's as simple as that. Now we can talk about the periods of sine functions. Now, what is the period of a sine function? It is basically one cycle of the sine function. Now, as we all remember, the sine function always starts at 1, then it goes up, then goes down, then goes down again to its minimum, then it goes back up. Now this is basically one cycle of, or one period of the sine function. And assuming that the frequency is just 1, then this is always 2 pi. And if that is 2 pi, then this is always pi over 2. This is pi. And that is 3 pi over 2. So those are the basic intervals for maximum, minimums, all of that. And it has direct correlation with your maximum and minimums. So if you remember, if your amplitude is equal to 1, then your maximum here would be y equals 1. Your minimum here would be y equals negative 1. It's as simple as that. Now let's talk about the x-intercepts and the y-intercepts of the sine function. Now, the x-intercept is simple. The x-intercepts is basically n times pi. Now, why is it n times pi? Because every x-intercept, every time the graph passes through the x-axis, it's always a multiple of pi, assumingly if the frequency is equal to 1. But of course, these x-intercepts can change with transformations. So if the frequency is not exactly 1, then your new method for finding x-intercepts would be n pi over b, with b being your frequency. Now, for the y-intercept only changes if you have a horizontal shift, which means adding c to the inside of x. Now, to get the y-intercept, all you have to do is just to substitute x into 0. That's all you have to do. Substitute x equals 0. Now, in the first place, why are we talking about sine functions? Now, sine functions can be seen literally everywhere because it's what you call a periodic function where it repeats forever, infinitely. And this could be seen in physics, specifically sound, music and arts. And did you know that sine waves produce the purest form of sound? Just listen to this. It's so pure, right? And with the sine wave, you can figure out the individual frequencies of the 12-tone temperament scale or the chromatic scale of the standard keyboard. Which means from A4 all the way to G sharp 5 or A flat 5. Now A4 is equal to y equals sine of the quantity 2764.60 times x. Now B flat 4 is equal to y equals the sine of 2928.52 times x. Now B4 is equal to y equals the sine of 3103.47x times x. Now C5 is equal to y equals the sine of 3289.37x. And then so on and so forth. So that's basically sine functions in a nutshell. You can see it anywhere through the vibrations of your hands, or through musical instruments, through the vibrations of any sort of instruments. You can see sine functions is there. It's present in physics and it can make the most beautiful sounds ever you might hear on Spotify or Apple Music. That's it. My name is Jari DECANO and thank you for listening.